RCEs are quite strange because on one hand, they are possible in many different functionalities, but in practice, they are quite rare and very valuable. So if you want to improve in finding RCEs, you're in a good place, because in this video, I will show you in what functionalities I observed them during my case study of 126 disclosed bug bounty reports. Enjoy! So this was definitely the most difficult case study, because I always try to somehow aggregate those labels together, but RCEs were completely all over the place. So in total, I have 13 functionalities and we'll go through them one by one. And the most common one is some kind of import or sharing functionality. And it's definitely something that you should pay attention to as one of the most critical functionalities. For example, we had a lot of those bugs in GitLab where, for example, you can migrate a repository from one GitLab instance to another. And it's a very dangerous functionality because you have to copy some files from one place to another, and every single interaction with a file is a place where RCEs are possible. Here, for example, to check a size of the archive, the system level command would be executed, and it is quite a complex report. We will not go into the details of it, but the bottom line is it was just quite a complex functionality. There was a lot of source code review involved here, but in the end, the payload is not so complex. It just, the simplest escaping of the argument, and you could inject your own comments. So similar thing here in GitHub this time. That one was in GitLab. This one is in GitHub. Here as well, you have the processing of the file. This time it's GitHub pages, creating GitHub pages, and it would process YAML files with apparently some insecure configuration, which would allow you to create an arbitrary file. And if you can create arbitrary files, you can often get the RCE quite easily, and it's the case here. This report was $25K. The previous one was $33,000. We'll now go to the second most common category, which unfortunately is called other, because these I just couldn't fit to anything else. For example, you have this bug, which I would never think that this is something possible. We have exposed Git repository, so the hunter could see the source code. Nice that he also included the recon steps that he took, and turned out that the source code looked like this. You had some hard-coded secrets in the source code, and if those secrets were correct, the application would just execute system level commands without any escaping. And yeah, normally without those secrets you couldn't do it, but just leaking the secret was enough to execute arbitrary commands here. And it's interesting because I saw this report and I thought it's like 2015 or 2016. It's 2023 and it's $10,000 of bounty. And yeah, most of these cases in the other functionality, in the other category, is something quite specific. Then we have file uploads. And when we take a look here at those average bounties, we can see that the average bounty for file uploads is a bit lower than those above it and below it, but the difference is not huge. But when we take a look at them here, we can see bounties are not so great in this category. And the reason is many of them are just the simplest web shell uploads where the application would do no verification. And it often happens in smaller applications, in applications maybe where the company doesn't have a proper security team. But the average bounty is bumped up by this 50,000 bounty from Apple. But if we take this one away, let's do it like this. If we take this one away, the average bounty goes down to $2,700, which is way less than anything else here. And before you ask me, because every single video like this has a comment, can I access this database with those reports? So this video is a part of the case study, which is in BBR Premium, which is behind the paywall. If you are a BBR Premium member, you just scroll down to the bottom of the article, which is quite long, to be honest. And then you have the database embedded here, and you can also filter it. You can also export it. You can do whatever you want. You can download it to the tool of your choice. And you can also access the direct Notion link here. Because I use Notion, I love Notion. So I decided to also add the Notion option for those of you who also do this. And if you want to join, now is the good time, because this video comes out when the Black Friday promotion starts, and it's the only promotion of BBR Premium for the whole year. And it's actually the last chance ever to get BBR Premium at this price, because before the next Black Friday, there will be a price rise. So the next year's discounted price will be higher. So it is the last chance ever to join at the $80 price mark. And also, if you do this now, you lock in the lower price forever. So every year you will be, your subscription will renew using the lower price. So now it's a very good time to join. But coming back to our reports, you're probably curious, what is this $50,000 report to Apple? And I also covered it on my channel. I will link all the videos that I mentioned in the description down below. And it was functionality, or actually the framework, Lucy. I've never heard about it, but they were able to convince the Lucy with some parameters and some templates to create an arbitrary file. And from there, the shell was possible. So it's also a shell upload, but it's definitely not an easy one or a simple one. Next, we have authentication. And authentication, I know there are a lot of bugs there, but I just wouldn't expect RCEs to be precise. And there were some, I would say, random ones, like this one, where the application would just take the value from the cookie and evaluate it. So we have the payload here. I'm not sure if this screenshot is visible, but there is base64 encoded command here, which is just executed by the server. And unfortunately, I cannot give you a recipe on how to find bugs like this, because it just looks completely random to me, and I definitely would not find this bug without the source code. But one pattern in authentication that I saw, and I want you to know about because it can be useful, is that sometimes the session cookie is a serialized object. And it's dangerous, because if you could get your arbitrary object to be deserialized, you could get an RCE. So to prevent this, all modern frameworks sign those cookies cryptographically, so that you cannot create your own cookie and get it to deserialize. You need the signature to be valid. So in practice, you need the server to generate the cookie. But the thing is, if you can disclose the secret used to sign the cookie, you can get an RCE. For example, here we have verbose errors in Rails, in the RAG framework, and the verbose error disclosed the cookie signing secret. So in this case, if you find something like this, do not report it straight away. Do not report that the application disclosed some secrets, even if they look good. If you disclose the cookie signing secret, you should create your own malicious cookie with a malicious object and sign it using that secret, and this will get you an RCE, like in this case, and this was a $5,000 reward. Then we have something that I called high privilege functionality, and the difference here is that the functionality is supposed to execute code, just the attacker shouldn't be able to. For example, the first report that I have here, the functionality is like cloud-based stuff. So by default, you can execute code on your instance, but there was a CSRF, and CSRF doesn't sound like a $30,000 vulnerability. But if the admin has access, or the user has access to execute code, and this functionality has a CSRF, then all of a sudden your CSRF is worth $30,000, like here. And the very interesting thing that we had here was the origin validation, because there was some fuzzing involved. And the key here to bypass the origin check is this address. Turns out that this piece, which is the underscore subdomain, which looks a bit like the emoji, it was enough to, that the website thought this is the origin and it looks valid because it ends with azurewebsites.net. But the browser thought that, this whole thing is the origin and this is attacker's site. So a very nice CSRF, also nice write-up because he also disclosed what characters he tried and what worked, what didn't. So really, really, really interesting case here and a really good bounty for this. Then we have a kind of similar case because we have cloud-based functionalities, and here as well you can execute code on your own instance by default. But the thing here is the vulnerability allowed either the escalation to instance of another user, or it allowed to execute code on the host of the where you shouldn't be. Basically, you had a way to escape some kind of sandbox. And we'll not go into the details here because we have a lot of bugs to cover which are closer to web-related bugs. For example, this first 30K attack was done via exposed kubelet, which is a Kubernetes thing. The second one was via exposed Docker socket. So these are not really web bugs. So we'll continue to the next category, which is templates. And most of these are server-side template injection bugs, which, to be honest, when I learned about this vulnerability, I thought it's much more common, and turns out it's actually not. This report is probably the most common example that everyone uses when they want to show this vulnerability. It's in Uber found by Orange Tsai. Your name would be evaluated as a part of the template in the email you received. So you would inject something like this, which contains the Jinja 2 templates. And when you would receive an email, it would be evaluated, and it usually can lead to a remote code execution. Interestingly, in this case, Orange was not able to exploit it as an RCE because of the length limit, but Uber still probably evaluated it on their side, and they paid $10,000 for this vulnerability. And the next category I have is also a way to exploit another vulnerability, which is SQL injection. I also talked about it in the SQL injection case study, which I recommend you to watch. I also am going to link this in the description down below. But the thing is, in some cases, in some configuration, with some configuration options, and in some database engines, you are able to directly turn SQL injection into a remote code execution with a query like this one. And with this, the next functionality is installing packages. So it's a bit different because it often occurs earlier in the development lifecycle. So these are not really bugs in the application itself, but somewhere before the application is even released. And here we have 8 reports, but 7 of those are dependency confusion vulnerability. This one I also created a video about. It's a very interesting and novel attack scenario which Alex Beerson discovered in 2020 and published in 2021. And it was basically a way to confuse a package manager to install your malicious package instead of a company's internal package. So when they would use something like this, Auth PayPal, you could convince the package manager to install your Auth PayPal package, which you can publish without any problems, because this one was private. It was in private PayPal repository. So you published Auth PayPal to a public repository, and if your one would have a higher version, so you would just use version 99999, it would install your package and it would execute your code on the developer's machine, maybe on the server as well. And bounties here were huge. He only mentioned 3 companies with bounties, and we have 40, 30, and 30K. So it's already $100,000. And he also mentioned a few more payouts, but didn't say exactly how much he got for them. So I couldn't put them here, but definitely the attack worth it. And also here we have other dependency confusion reports also paid really, really well. And if you're wondering what's the one attack which is not dependency confusion in this category, it's this one. Basically, Mapbox used some script that pulled code from an S3 bucket, and then they stopped using the S3 bucket, but this script would still pull the code from this bucket. So Franz Rosen would claim this bucket, put his code there, and this script would pull this code and execute it. So they paid $12,500 for this report. The next category I called 0-day, and these are basically vulnerabilities in products and not in specific applications. For example, another report by Orange, this time in Twitter, and these are vulnerabilities in the Pulse Secure VPN which Twitter used, and we can see 6 different CVEs here, really complex and really long explanation, but the bottom line is it ended in a remote code execution and I got $20,000 for it. So bugs like this can be worth a lot, especially that if they had the vulnerability in the VPN, they could also report it to many other companies that have bug bounty programs and that are using this VPN. So bugs like this can be really, really worth a lot. And another vulnerability that you should pay a lot of attention is any kind of image processing, or to be fair, any processing of any file, because we can see 5 of these are image magic vulnerabilities, which you can see the dates 2018, 18, 19, 16, 18. Quite an old vulnerability that was very common in those days. Also in the SSRF case study, there were quite a lot of those. But in any case, any functionality like this should be your focus point. Here we have another vulnerability in GitLab. I also covered it on my channel. And this is a 0-day actually in the EXIF tool, which is used to strip metadata from a file. And it's a very interesting one because the code that was supposed to not make this possible didn't predict that the new line just after a backslash and would process it incorrectly, which could lead to you basically being able to inject your own code and execute your own code inside of a file. So also a really interesting one. Also a lot of code review going on for this. I believe it's not possible to find a bug like this with a black box approach, but definitely worth it because it's $20,000 from GitLab. Then there is another functionality which I think it's quite obvious, and you probably won't be surprised that when the application executes command as the functionality, it should be your focus point, because it's quite natural that when we see a command being executed, we immediately think about command injection. So I think it won't be the most interesting takeaway from this case study, but take a look at this bug. It shows that not always you actually have to escape the command to make a vulnerability work. Here we have another report by William Bowling, and we have a functionality where it would run the git command under the hood to make some diff. And at the first sight, it doesn't look, this part does not look sensitive at all. The file name, it was not vulnerable in this case. It was probably sanitized or something. But the commit 1 or commit 2 positional arguments, they do not look like something where you can inject your own comments. But the thing was that William created a branch with a name like this, a branch with a name --output equals and a file name. And when it was put into the command, then it was put here as commit 1 or commit 2. And all of a sudden, instead of being a positional argument, you were in the named argument called output, because still, even though he had a branch name like this, he couldn't just escape the argument and just inject arbitrary comments. It wasn't an easy case like this. He could just inject another argument into this comment, and this argument allowed him to create arbitrary file. And as you probably already know from this video, creating arbitrary file often allows you to reach a remote code execution, and it was also case here. And now we'll step to the quite an interesting case of a bug bounty program where all those three reports in the category I called SMTP DB configuration are 5K vulnerabilities in the same program called Ivan, which I've never heard about. But what it does is it allows some configuration, some database connectors or some SMTP connectors, generally quite an advanced configuration. And those connectors were vulnerable in a very similar way. For example, here we have the SMTP server configuration, and the password argument was vulnerable to a pretty standard command injection, I would say. And it was actually due via the new line injection, so you couldn't like inject the apostrophe or a quote. You could the new line injection, and the other two 5K reports for this program were kinda similar. Next, we have a category called making requests, and if I really wanted, this could be the most common category, because in the SSRF case study, I observed, I think it was 28 SSRF reports that resulted in leaking cloud metadata credentials, and cloud metadata credentials often allow you to execute code. So if I really wanted, I could copy reports from that case study to this case study, and then making requests would be the most common functionality vulnerable to RCEs. But I decided that, copying, it won't add to the discussion a lot. So I only have 3 reports here where making requests, or SSRFs, because all these were SSRFs, were directly turned to RCEs. And I really like this report, because in all the SSRF word lists or ways to escalate SSRFs, you see the Gopher protocol being used. And to be honest, I've never seen it work before this report, and I don't even know what it's supposed to do. But here it was used to achieve an RCE, because the Gopher protocol was used to first detect the Redis instance on this port, and then this URL was used to run some Redis commands, which allowed turning this SSRF into an RCE. So I really like this report. I really like to see the things which I always see in word lists and I don't really understand. I love to finally, see them working in the real life. And finally, only one report in the functionality which I also think you should pay attention to, because it's a headless browser. When the server, runs the browser to potentially render a PDF, to generate a report, or do whatever. And here the Elastic, or Kibana to be more specific, they used a vulnerable version of Chromium. So it was vulnerable to, if you could run your arbitrary JavaScript code in this browser, you could achieve an RCE. And the interesting thing is that this report is somewhat theoretical, and every content about bug bounties says to only report real threats. But here the hunter didn't have the way to execute arbitrary JavaScript in this browser, but he decided to report it anyway, and he just wrote very honestly that there is no RCE at the moment, but you're just an XSS or HTML injection or an open redirect away from the RCE, and Elastic decided to reward him with $10,000. So it just shows that in very specific situations, you can report vulnerabilities without a direct impact, but you have to be very, very cautious with this. And that's it. That's all the functionalities that I observed during this case study. If you enjoyed this video with part of the case study, I encourage you to Join BBRE Premium and see the full article in the archive, as well as other case studies that I've done. I remind you that now is the best time to join because it's the Black Friday deal. If you're interested, go to bbre.dev/premium.